start having a look at Pythagoras, and I'm going to give you a brief introduction and stress brief. I'm going to show you, using this diagram in this picture here, I'm going to show you the basic idea of where it comes from and some of the simple applications you can use this for. We're also going to talk a little bit about how we can use some of the surds to keep our answers a bit more accurate, but also you can use your calculators to help you here as well. So let's just jump straight in. This diagram here shows the basic principle behind Pythagoras. So imagine you've got a right-angled triangle, very important that it's right-angled triangle, and you took three sides, A, B, and C, of any size, and on the edge of each of the triangle you can see we've drawn squares. So we've drawn square C, A, and B. Now to find the area of each of these triangles, so this one here would just be lowercase c squared. Lowercase for a side, uppercase for something else. A is a squared and B is b squared. So think of it as a triangle with three squares either side, a squared, b squared, and c squared. And we're looking at the relationship between them. Then we can try and substitute into numbers and see what we notice. So let's imagine we had a triangle that looked like this with 3, 4, and 5. If we were to work out the area of this square, which would be 3 by 3, the area would be 9 because it's 3 squared. The area here would be 4 squared, which is 16. And the area here would be 5 squared, which equals 25. Those of us who are quick at their mental maths will notice that if we take the two smaller ones, the 9 and the 16, all together they add up to the 25. Because 3 squared plus 4 squared is 5 squared, because we can use square numbers. If we think of that algebraically, what that is telling us is that the area of C here is equal to the area of A and the area of B added together. If we were to write it in terms of squared, we could say lowercase c squared is equal to a squared plus b squared. And this is the most common form that you see Pythagoras in. What it's saying is if you have a triangle like this and you draw squares around the edges, the area of the biggest square is equal to the area of the two smaller squares added together. But we want to talk about today triangles. We're not going to talk about the squares. We want to talk about what A and lowercase b mean. Well, let's just keep at the top here what we've just said. C squared is equal to two smaller squares added together. Square C is equal to the two smaller squares put together. But what about if I want to talk about just C on its own? Well, we've been talking a lot about square roots. What we can do is say, well, if we've square rooted this, let's go off the top, to get this, we can also square root everything else. What about if we wanted to rearrange this equation? And again, I did stress brief introduction. So, c squared equals a squared plus b squared. So we can say that c is equal to the square root of a squared plus b squared. But what about if we want to change this so let's say a squared is the subject? Maybe I want a squared to be the subject. Well, that's going to equal c squared minus the b squared. We're going to subtract b squared from both sides. And again, we can make a the subject by square rooting everything else. Why is it a subtraction? Well, think about it in a simple way. If we know that these two here together, two small ones make a big one, then by taking this one and cutting out b, imagine you cut out like b, you'd be left with the area of A. So the big one minus the smaller one. Finally, we can do the same thing. We can make b the subject of the formula. B squared would equal c squared, big one, minus the smaller one. And again, we can just get b to be the subject by square rooting everything we've got. So now we can talk about just the triangle. The longest, the next longest, and the shortest. So what is Pythagoras Theorem? Well, it talks about right angle triangles. It looks at something called the hypotenuse, which is always the longest side. So if you have three sides of any triangle, whether it's right angled or not, hypotenuse is the long one. And it says, first of all, that the two smaller squares, if you draw them on the edge, the little diagram that we did here, the two smaller ones make the biggest one. And we then said by rearranging, using our algebra skills, we can work out the formula for each of the sides, just A, B, and C, not the squares, just A, B, and C. And we said, well, we can do this by using some of our square roots. C is the longest, so we need to add the two smaller ones together, the two smaller squares, and then square root them. Notice they're squared first, then square rooted the whole thing. Make sure you type that into your calculator right. And then the smaller ones are going to be the larger. The largest, which is C, minus the other small one. So those are our three formulas. Find A, B, and C. And I'm going to show you how we can use those to find missing lengths in a triangle now. So let's just jump straight into an example. Here's a question. It says calculate the length of the hypotenuse H. It gives you the two sides 7 and 8, and it says find H. Now I know you're thinking we've used A, B, and C. Now we're talking about H. What's going on there? But don't worry. Easy little trick you can do is you can just label your triangle. We know the longest side is going to be C, and the other sides are going to be A and B. We choose the right formula. Well, we want to find out what C is. So we're going to use the formula. We can say, well, I know that C is equal to the square root of A squared plus B squared. So I put the numbers in. And this is where we're going to use the roots. We still don't know what C is. But we know that A is 7 and B is 8. It's a slightly smaller pen. C. So 7 squared is 49. 8 squared is 64. 49 plus 64 is 113. So we can leave our answer as a square root. And this is what we call leaving our answer in surd or root form. And that's absolutely great. If you can leave your answer like that, that's the most exact answer. Like a fraction, okay, it's the best form. And if you do get to that point no further, that's absolutely fine. Some questions will ask you to write it as a decimal, however, so you need to then use your calculator. For those of you who don't know, you can use your Finder window, your Spotlight search as a calculator, but it would be better if you can have an actual calculator or use one online. Okay, but if you do that, you do square root of 113 and it will give you a decimal value. So, just to clarify, okay, we've put the formula in first, then we put the numbers in, and finally we put in our answer as a square root. And doing this on the calculator, we'll just do it to 2 decimal places, would give you something like 10.63 centimeters. Most important thing here is you choose the right formula. Let's try another one. Here is a rectangle. Oh my god, we've just been doing triangles. Don't worry. It says calculate the length of the diagonals. So diagonals are from one corner to another. What happens if we join the diagonals together? We can see that in this bit here, we now have a right angled triangle. The right angled triangle looks something like this. So now we can see again, it's saying D for diagonal. We can use our letters C, A, and B. I'm going to do it the other way around just to show you it doesn't really matter. A and B, doesn't matter which way around you label them. C is always the longest. Use our formula again. Adding together because we want to find the longest. Put in the numbers. Oh, no, it's 8 squared, sorry. Get out of it. So we do 16 squared, which is 256, plus 8 squared. And that gives us a square root of 320. 320 can be simplified. So for example, we could say it's 16 and 20, or even better than that, we could say it's 64 times 5, which is 8 root 5, and that would be our best answer because we leave it in root form, which is super quick, and you can do that hopefully as you get more practice. You can do that mentally, but if you are not happy with that, then you can use your calculator and you can say root 320 is equal to 17.89. Ooh, that's a highlighter. 17.89 for 2 decimal places. So you can leave it in surd form or decimal form. If you're doing a 2 or 3 part question, keep it in surd form because the decimal goes on and on forever, whereas that there is much easier to write. Okay, let's keep looking at some examples of how we can use this. Now we are trying to find x here. X, we can see, is not the longest side, so that does affect how we use our formula. Jumping back, we can see that it's like that one on the side. So let's label our triangle. Let's call it C, B, and A. Formula for B is equal to the square root of the longest minus one of the other shorter ones. Put in the numbers. 26 squared minus 24 squared, all square rooted. You can type that into the calculator. 26 squared plus minus 24 squared. And that actually gives you 100, but it's the square root, so B is equal to 10 centimeters. When it's a whole number, obviously you don't leave it in a root because it can be simplified, and the decimal and the root are the same thing once they're simplified. So the key thing here was the formula has changed. Shorter sides involve subtraction. Here's an easy, alliteration to remember. Short side subtract. SSS. Let's try another one. Oh, we live in the dream. Let's make it a bit bigger in case you can't see it. Now it's giving you a perpendicular triangle, which is not a right angle. Ooh, you can see the little solution thing popping out. Let's get rid of that. So here we need to make it into a right angle triangle because we know that at the moment Pythagoras Theorem only works with right angle triangles. But good news if it's isosceles is we can split it down the middle like so. And it makes 2 halves of a triangle with that dotted line. Let's label it A, B, and C again. I'm going to label it differently. I'm going to call that one A, that one B, and that one C. As long as C is the longest, it does not matter. Formula, square root, longest minus the other short one. Substitute, C squared is 6, 2. So A is equal to 36 minus 4, which is equal to the square root of 32. Which is equal to 16 times 2, so it's going to be 4 root 2, and that is one of our answers. Or we can type the square root of 32 into the calculator, and we can say the square root of 32 is 5.66 centimeters. Highlighter again. So again, it's just choose the formula, put in the numbers, and then give your answer as a root or a decimal. Sometimes the question might have a little step where you need to draw a diagram. Oh, a question with a diagram. This is a very common question you see with Pythagoras. It talks about west, east, north, and south. Hopefully from your general knowledge of the world, we know that we can do things that look like this. Any of the acronyms you've done as a child, naughty, elephants, square, water. So it says here's our ship. Let's give ourselves a starting point here. It says the ship goes 300 kilometers west. So it's going that way. And it goes 300 kilometers. It then says, I'll do it in red so you can see the difference. It then goes 100 south, so it's going that way. It goes for 100 kilometers. It started here, so it's ending here. And you can kind of join that together with a dotted line. It says, how far is the ship from its starting position? So it's asking us, once you've drawn the diagram, hopefully you can see, there's our diagram. It's asking us to find the hypotenuse. And the better diagram would be here. If you're getting a bit more confident, you could maybe just go straight into a substitution. D is equal to the square root of the two shorter sides added together. The numbers you're going to get are going to be quite big, but don't worry. So you do 300 squared plus, so it's 90,000 plus 10,000. So D is equal to the square root of 100,000. And then you're on your calculator and you go, oh, 100,000, that looks like it might be a good root. But unfortunately, it's not a million, so you can simplify that root, or you can write it as a decimal, 316.23 kilometers. Or you could simplify this root, maybe you'd say it's 100 times 100, which would be 1,000 times 100. Oh, no, 10,000 times 10. So it would be 100 root 10. Let's highlight them all in super duper yellow. More examples? Nah, we're okay. So, summary. That's the diagram. That's the key diagram. Remember, it's all about areas. This is the first version of Pythagoras that deals with the areas. Today we're dealing with lengths, so we want to talk about A, B, and C. A and B are shorter, they're interchangeable. C must be the longest side. If you think about it, A and B are short, short sides subtract, and the longer sides add. Just use those formulas, pop the numbers in, and you can leave your answers as roots. You can leave your answers as decimals or whole numbers if they go to nice whole numbers. Keep these, I would say, make sure you write these down in your book, because you're going to be referring back to them lots and lots and lots. So it might be a good idea to write them at the top of the page, and then you can just keep referring back to them. So give this a go. That says grade 6, just realised that. Oh dear, it should say grade 8. Embarrassing. And see how this goes. There's simple questions, there's more complex questions. Some of them you might even involve a diagram, some of them are word problems, but all of them, and I mean literally all of them, will boil down to using roots, which we've already done, and these three formula. Give it a go. Enjoy.